Hey, Dr. Smith. I'm in your online forecasting class, and I couldn't get anybody to respond to my email to be a partner, so I did mine by myself. And I decided to do a presentation on forecasting um, U.S. airline passenger volume using macroeconomic indicators. And the goal of this research is to understand how broad economic forces influence airline passenger demand, and also to understand and build a statistical model capable of forecasting changes in monthly passenger volume. Airline travel is extremely sensitive to economic conditions, and accurate forecasting helps the industry make decisions about pricing and fleet planning and scheduling long-term investment. So in today's presentation, I'll walk through the motivation for the study and the data set that I constructed, and I will show the results of the model and how those findings connect back to the academic research and industry research. So to begin, I pulled two academic literature reviews and an industry literature review, which will be on the next slide. And I wanted to talk about the existing research that's already been done about the airline demand. One of the most influential academic studies that I found when I was looking for one was the fuel prices and income effect demand study that was done. Um, their 2002 analysis looked at dozens of airline demand studies across different time periods and regions. And what they concluded is that two economic variables consistently predicted airline demand, and that was fuel prices and disposable income. So fuel prices shape the cost structure of the airlines, which in turn affects the ticket prices and profitability of what the different airlines can achieve. Disposable income reflects the ability of consumers to spend money on discretionary travel. Their results suggested that when fuel costs rise or when consumer income weakens, airline demand tends to fall. This study is important for my project because it supports including fuel prices and income as predictors in my regression model. Another key study comes from the unemployment and sentiment influence travel research that was done, where they examined the dynamic relationship between the airport or the air transport demand and the broader U.S. economy. They found that unemployment and consumer sentiment are especially powerful in determining the level of air travel. Their research showed that periods of rising unemployment correspond with noticeable declines in air travel, not only because consumers have less money to spend, but also because economic uncertainty reduces people's willingness to travel. And consumer sentiment is how optimistic or pessimistic people feel about the economy. And the authors found that this sentiment has a statistically significant and positive impact on travel demand. This validates my decision to include both unemployment and sentiment as explanatory variables. I use these two studies to form the foundation of my model, and they highlight how airline travel is intertwined with the macroeconomic conditions, and they provide evidence that fuel prices, income, and unemployment and consumer sentiment are relevant determinants of passenger volume. So in addition to the two academic research papers that I found, I also found a industry research paper from the International Air and Transport Association. And their annual economic performance reports summarize the financial health of the airline industry as a whole, and they identify the economic conditions that tend to move air travel up or down. And according to them, the three indicators consistently correlate with changes in air travel are oil prices, inflation, and industrial production. The oil prices matter because they feed directly into the airline's operating cost. Inflation is linked to overall economic momentum and affects both consumer purchasing power and the cost structure of the airlines. And industrial production creates economic activity, business travel demand, and global supply chain movement. What the AITA's findings show is that the broader macroeconomic conditions play a significant role in determining how many people fly. Which, when you think about it, makes sense because the more people that are conducting business, um, they'll have to travel for business, and then the more people will be making money and they'll be able to afford to travel. And this industry perspective supports and expands on the academic studies previously mentioned and affirms that including the CPI, the industrial production, and oil in the model would capture additional economic forces relevant for forecasting airline passenger volume. So this was a very time-consuming part of the project, was building the actual data set with the monthly observations, because I had to make everything match accordingly. And I also wanted to look at post-COVID, um, because most of the studies were pre-COVID, and I wanted to look at post-COVID. So I narrowed what I was doing from December 2020 through August of 2025, because it had the most. August 2025 was the most recent data that I could get from every variable that I was using. And this gave me a total of 57 months of data, and all the variables were collected from the from federal and industry sources. Passenger volume was my dependent variable, and the predictors that I had included jet fuel prices to capture cost pressures, and disposable income to capture consumer purchasing power. And then I used unemployment to reflect labor market conditions, and consumer sentiment as a measure of economic optimism. And then I used CPI to capture inflation trends, and then industrial production to represent economic activity, and oil prices as another cost measure. One of the most important parts of preparing the data set was making sure that all the variables were properly aligned by month. For example, when I was cleaning it up, the oil prices were reported daily, so what I did was take a monthly average. Um, that way I could align it with the rest of the data. And then once everything was aligned, I checked for missing data, and then I verified the ranges and confirmed that every variable had complete monthly coverage. So, to examine how these economic variables influence monthly passenger volume, I estimated using an ordinary least squares regression model. Um, I found that this model was appropriate here because the dependent variable is continuous, and we are modeling linear relationships between broad economic indicators and the number of airline passengers. And a key advantage of this model in this setting is that each coefficient directly shows how passenger volume is expected to change when a predictor increases by 1 unit while holding the other variables constant. The table summarizes the regression results. Several predictors are statistically significant and line up well with the economic intuition that you would think of when you think of how the economy affects airline passenger travel. Um, Unemployment has a large negative and highly significant effect, meaning that the higher unemployment is strongly associated with reduced air travel. Jet fuel is also negative and significant, which fits the idea that higher fuel costs lead airlines to raise prices, and or they have to reduce capacity, ultimately lowering demand. Consumer sentiment is positive and highly significant, suggesting that people are more willing to travel when they feel confident about the economy. And CPI is also strongly positive and highly significant, reflecting that periods of economic expansion when the prices tend to rise are often accompanied by higher travel activity. Um, the industrial production has a positive coefficient and is marginally significant, which is consistent with increases in business activity, leading to more corporate and freight-related travel. Um, Income and oil, while included to provide a full economic picture, are not statistically significant in this sample, and their coefficients should not be overinterpreted. Their weak performance may reflect shared variation with stronger predictors already in the model. Um, so overall, the combination of strong t-statistics and low p-values and economically sensible coefficient signs for the major predictors supports it's likely that the results are reinforced, and that the model is capturing uh, a meaningful economic relationship. All right, so most importantly, does my model fit? And my model explains about 97% of the variation in monthly passenger volume, which is exceptionally strong for forecasting. The overall F test confirms that the predictors significantly improve prediction. And while the model structure appears appropriate and the residuals do not show a curvature, the spread of the errors is larger at lower predicted values and tighter at higher predicted values. And this suggests that the assumption of the constant variance is not perfectly met, though the model still performs well overall. Okay, so these next few slides, I'm going to be including some charts that were generated in SAS when I ran my model. And this chart right here compares how far off the model's predictions were from real passenger numbers. And if the model were perfect, all of the dots would line up evenly around that line in the middle, around the zero line. And instead, we see the errors are much larger when the predicted passenger counts are low, and they shrink as the predicted values get higher. And that means the model is less consistent when there's a month that has a lower passenger volume, and it's more accurate in the higher passenger months. And um, this uneven spread of the dots is a sign that the model's errors don't stay the same across the prediction levels, and there's no obvious curve or shape in the dots. So the basic linear pattern seems fine, but changing the size of the error suggests that the model doesn't meet the equal variance assumption perfectly. Okay, so this next chart is the QQ plot, which was generated in SAS, and it compares the distribution of residuals to a theoretical normal distribution that's represented by the line. And as you can see, most of the points lie mostly along this diagonal line with only a few deviations, especially more toward the bottom. And this means that the residuals are appropriate or approximately normal, which supports the accuracy of statistical tests used in regression. Um, Normality is not required for the prediction, but it does matter for inference. So this plot provides reassurance that the t-test and the p-values we rely on are trustworthy because, as you see, all the dots are relatively close to the line and follow it. Okay, this chart that SAS generated for us is the Cook's distance chart, and it evaluates whether any individual observation exerts excessive influence on the regression model. And in this data set, you can see there's several early observations shown on this chart, and the values are far above the rest. Specifically, if you look at the first few observations and the first few months, they're highly influential and could meaningfully affect the estimated coefficients if removed. Most of the other observations have very small Cook D values, indicating they don't individually impact the model. However, because the early influential points that you can see by the taller bars on the graph, they do have a lot of influence on the model, and the model stability depends significantly on those. So this is the last chart that I pulled from SAS, and this is the actual versus predicted scatter plot, and it indicates that the forecasting model performs extremely well Each point represents 1 month that was observed. So there's 56 point or 57 points that are on here, and the tight clustering of the points around the 45-degree line shows that the predicted passenger volume closely matches the actual volume for nearly every observation. And there's no clear pattern of over or under prediction and no influential outliers because they're all relatively right along the line. And this visual fit is consistent with the model's high R squared value, and it supports the conclusion that the model provides reliable forecast of what the passenger demand is based on the variables that we're relying on. So to put my results back into plain English, people fly more during periods of economic optimism, which is represented by that consumer sentiment, and when there's rising prices and strong industrial activity. They fly less when there's unemployment rises or when fuel prices are high. So, in other words, airline demand reflects a combination of consumer confidence in the economy, um, economic fundamentals, and cost-related pressures. These insights are intuitive. You'd probably think of these as being pressures. Uh, Pushing ticket prices or the ticket prices, regarding how many people are going to fly, and um, it would match like what you would intuitively think would match what we observe in this model, and it would be similar to the real world travel behavior. So these findings connect back to the literature that we saw earlier in the presentation, because one of them emphasized the importance of income and fuel prices and the importance of those things. And our model confirms the role of fuel cost. And another one of the literature reviews, it had the importance of unemployment and consumer sentiment and how they feel about the economy. And our results strongly reinforce that conclusion. And the industry study that I looked at emphasized inflation and industrial production. And again, our model supports those relationships. And the alignment between this model and the previous research increases the credibility of the findings. And it shows that the macroeconomic indicators are reliable predictors of air travel. So, in conclusion, I found that this forecasting model demonstrated the macroeconomic indicators and how they play a powerful role in shaping the U.S. airline passenger volume. The model also is statistically strong, um, uh, economically meaningful too, based on how the economic indicators are pressuring the number of passengers. And it's also consistent with the established research that we reviewed in the beginning. So for future research, it would be valuable to explore the lag effects, such as how changes in consumer sentiment or changes in fuel prices affect travel in subsequent months. Like how long does it take to affect after gas prices go up or after consumer sentiment goes down? And uh, maybe compare it to international travel data and see how the United States travel data compares to that, because this was only pulled on United States travel. And expanding the data set or incorporating structural breaks could also improve long-term forecasting accuracy. I only did 57 months because I wanted to focus on post-COVID. So if you expanded it farther and maybe dropped off the COVID time period, it'd probably give you a better, more accurate model. So overall, I believe this model provides a very strong foundation for understanding and predicting airline demand.